In this video here, we are going to be completing questions 5 and 6 for 2016. And I think those are both great questions. We finally see a funnel question. Finally. We haven't seen one of these yet, so I think this would be a good one to do. And number 6 is another sequences and series, which, all right, I want you to try them always, okay? And as we go through the video, I'm going to explain which ones I think are possibilities of being shown up and ones that are not going to show up because they're not on the curriculum anymore, but still, good problems to review. Okay? All right, let's start with A. And I think five y'all probably feel pretty good about. Okay? It says the inside of a funnel of height 10 inches has circular cross sections. Yeah, we can see that obviously above, as shown in the figure above. At height h, the radius of the funnel is given by r equals. So here's your relationship. Here's your relationship with your radius to your height. The radius will always be 1/20th of 3 plus your height squared. And this is between 0 to 10 because the height is 0 all the way up to 10 of this funnel. Okay. So now the units R and H are in inches, and we want to find the average value of the radius of the funnel. So if I want to know the average radius, that's asking for average value. Part A is not bad. Average is equal to 1 over B minus A, which B minus A is 0 to 10, so that's 1 over 10, integral A to B, so 0 to 10, of my function 1/20th 3 plus h squared. Okay, and there's something on my computer that prevents me from writing in this one section, and it bothers the fire out of me. Oh, now you will. What is going on? Why won't it let me do that, dude? That drives me so crazy. Oh, all right. Whoops. I got a little carried away there. All right, anyway, 1/20th. Hey, there he goes. 3 plus h squared dh. All right, that's the average value, right? 1 over b minus a times the integral a to b, 1/20th 3 plus h squared. Now, this is a Calc inactive problem, so unfortunately we have to do the math here and not just type it in our calculator. All right, so when I do this, I'm going to take out the 1/20th. It's a constant, so I'm going to have 1 over 10 times 20 is 200. And I'll go and integrate the 3 and the h squared. So the integration of 3 is 3h. Integration of h squared is 1/3 h cubed. And we're doing this from 0 to 10. Now, hopefully you can agree with me that if I plug 0 into this, it's going to cancel everything out. So all I really have to worry about is plugging in 10. So this is equal to 1 over 200 times 3 times 10 plus 1/3 times 10 cubed. And if you really want to, you can say minus 0. This is equivalent to 1 over 200. And honestly, guys, I mean, it's Calc inactive. If you left it here, I think you're going to be fine. But the answer key did it all the way, so at least I don't want to jip you from that. So 1 over 200 times 30 plus, is that 1,000 over 3? Okay, which if I continue up here, that's going to be 1 over 200 times, common denominator would be 90 over 3 plus 1,000 over 3, which would be 1,090 over 3 times 1 over 200, which is 1,090 over 600, which reduces down to 109 over 60. 109, oh, and then that is inches because we are finding the average value, that's inches. But again, what I circled in red, I'm sure you can leave it that way and just say inches at the end, and you'll be all right. All right, but average value, we know that it's a formula. We are all good there. right, B says find the volume of the funnel. Volume of the funnel. Okay. Well, notice how it said all the cross sections are circles. Okay, all the cross sections are the circles. So it's like having a cross-sectional volume here. All the cross sections are circles, meaning we're using pi r squared, and we're going to integrate that from 0 all the way up to 10. And that's all it is. I mean, that's all. That's what an integral does. It's going to add up the infinite amount of circles from 0 to 10 of pi r squared. So that's how you find the volume. Let's just put that into context. So the volume is going to be pi integral 0 to 10 of r squared, which is that quantity, and it's going to be 1 over 20 times 3 plus h squared, quantity squared. It's starting to do that mess again. dh. Okay. Which I'm going to go ahead and square and take out the constant. Like if I distribute the square to both my terms here, 1 over 20 squared is 1 over 400. So that's going to be pi over 400 integral 0 to 10. And if I distribute 3 plus h squared, I'm going to get 9 plus 6 h squared plus h to the fourth dh. Okay. Which, if I integrate this, try not to run out of room, but I probably am. That's pi over 400, 9h plus 2h cubed plus 1/5 h to the fifth, and we're doing that from 0 to 10. Again, 0 is going to make all that cancel out, so I'm just going to plug 10 in really. You can put minus 0 if you want, no big deal. But I'm going to say pi over 400 times 9 times 10 plus 2 times 10 cubed, which 10 cubed is 1,000, plus 1/5 h to the fifth, which is the same thing. 10 to the fifth is 1 with 1, 2, 3, 4, 5 zeros over 5. And then minus 0 if you really want to. Now, calc inactive means I can leave it this way for my volume. I would still put like if this is volume, this is going to be inches cubed. I would honestly leave it that way. But the answer key did simplify it, so I'll do that for you so I don't cheat you of an education here. That's pi over 400. And combining the inside, that's 90 plus 2,000 plus, and then 100,000 divided by 5 is 20,000. Okay. And if I combine that together, that's going to be, let's see, 90, 200, and 20,000 is going to be 22,090 pi over 400, which you can reduce by a power of 10. So it's going to be 2209 pi over 40 inches cubed. But if you left it in that first blue circle, you're fine. Just put inches cubed. All right. All right, that's part B, finding the volume. So again, just a formula. So part A and B are just formulas and then doing the math. And then lastly, part C. Part C says the funnel contains liquid that is draining from the bottom. There we go. Related rates. At the instant when the height of the liquid is 3. So like right here, we're at h equals 3. The radius of the surface of the liquid is decreasing at a rate of 1/5. So if I'm talking about the radius decreasing, I'm saying that this is dr over dt. And at this exact instant, what is the rate of change of the height? So what we're looking for is dh over dt with respect to time t, is dh over dt. So I need to have some function that has dh over dt in it. Well, why not? Let's take the derivative of the equation given. Then I'll have dh over dt, right? All right. So if I take that derivative, I got dr over dt is equal to, all right, and I'm going to rewrite this as r equals 3 over 20 plus h squared over 20. I just went ahead and distributed the 1/20. It makes taking the derivative a little bit easier because the derivative of 3 over 20 goes away. And the derivative of h squared over 20 is going to be 1/10 h dh over dt using power rule. Okay? And then we just plug in everything we know and we're good, right? It told me that dr over dt is 1/5, and that's negative 1/5 because it is decreasing, so it's a negative rate. It's 1/10. H, it says, was 3, and we're solving for dh over dt. So not a bad related rates problem. So if you solve this out, dh over dt ends up being negative 10 over 15, or negative 2/3, and this is a rate, so that's inches per second. There you have it. That is the related rates there. That's dh over dt, the rate at which the height is changing whenever the height is equal to 3. All right, cool. Here's the answer key. So for A, if we're doing the average, we got the integral, which is that. We took the correct antiderivative, which was that, and then we got the answer, which again, if you left it like that, or the first circle from part A, it's fine. Just make sure you put inches. 1 point for setting up the correct integral. 1 point for the correct derivative, which we did. And then 1 point for the answer, which again, if you left it like right here, you're fine, but I would again put inches cubed. And then C, 2 points for the chain rule, so finding this derivative, which we did, and then 1 point for the answer, which was negative 2/3 inches per second. All right, not the worst problem. I think funnel problem. I think we like those. I think those are good. And now on to our favorite problem that I know that everybody just loves, and that is a series problem. Okay, so I'll go ahead and tell you for this problem here, as I was looking over it and looking at the topics that are fair game, I guess, for the final exam, I would say part A and part C. Part A and C are my maybes. Part B and D won't be on the AP exam. Okay, so I would like for you to at least try A and C. C is not bad if you can get A. A can be a little tough. So let's just write it piece by piece here. Okay. All right. The function f has a Taylor series about x equals 1, so that's my center, that converges to f of x for all of x in the interval of convergence, which it hasn't told us that yet. That's how it works. All right. A series is going to map a function f of x for all x on an interval of convergence. Okay. It's known that f of 1, f of my center, is equal to 1, and f prime of 1 is equal to negative 1/2. And then for any derivative after that, like f double prime of 1, f triple prime of 1, f fourth derivative prime of 1, is given by this function here. So like if I want to know like what f fifth derivative of 1 is, I just plug 5 in for n and I'll get it. And that's for all n greater than or equal to 2. All right. Part A says write the first 4 non-zero terms and the general term for the Taylor series for f about x equals 1. So this is something I would maybe see them do. Okay, so let's make sure we're good at this. What is, by definition, what is a Taylor series? So let's start off by writing out the definition of a Taylor series for the first 4 non-zero terms and the general term, and we're going to build up to what the actual series is. So let's start with what we know. Okay, so by definition, a Taylor series. So I'll just say Taylor is equal to, okay, f, and this is about a center of x equals 1. Okay, so this is a Taylor series about x equals 1. is going to be f of 1 plus f prime of 1 times x minus 1 plus f prime, or second prime, double prime of 1 times x minus 1 squared, all over, and I'm going to put just over this constant, but it's the same thing, all over 2 factorial plus f triple prime of 1 over 3 factorial times x minus 1 cubed plus dot 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 plus, this is just a formula for Taylor series that we have memorized. It's the Taylor series is f to the nth derivative of my center 1 times x minus 1 to whatever nth power, whatever term I'm at, all over n factorial. Okay, and it starts off with n equals 0. Okay, perfect. That's just simply writing down the Taylor series. So if I want to have the Taylor series representation of part A here, I need to have this value, I need to have this value, I need to have this value, and I need to have this value. Okay? But thankfully, they give us a formula for this, all that stuff in red. The formula for this is given by that. Okay? So pretty much I already know what the general term is going to be. The general term is this, but instead of fn1, we don't have a function to take the derivative of, we have a formula for the derivative. Okay? So let's figure out all these boxed red values here. I know that f of 1 is equal to 1, f prime of 1 is equal to negative 1/2. Like, I know that, it told me that, right? Now to figure out these other two, so like f double prime of 1, that's at n equals 2. I'm going to plug it into this formula it gave me to figure out that derivative. So that's going to be negative 1 to the second times 2 minus 1 factorial over 2 squared, which, I'm gonna, okay, so negative 1 squared is positive 1. I'm gonna write this as, okay, so that's 1 factorial, so that's gonna be, yeah, I'm gonna say this is 1 factorial over 2 squared. And I want you to leave it that way, and you'll see why. If you leave it unsimplified, it's easier to see the general term here, okay? So that's what f double prime of 1 is. Now, f triple prime of 1 is equal to negative 1 cubed, 3 minus 1 factorial. Oh, don't be doing that now. Why is it that spot there? Over 2 cubed, which is equal to negative, because it's alternating, so negative, and that's going to be 2 factorial over 2 cubed. Okay. So now, if I want the Taylor series, I'm just going to plug in those red values into that red box, and I have it. Okay. So my Taylor series is equal to f of 1 is 1 plus f prime of 1 is negative 1/2. So I should probably say minus 1/2, okay, x minus 1, and then plus f double prime of 1. So f double prime of 1 was 1 factorial over 2 squared divided by 2 factorial. So I'm going to say that this is 1 factorial divided by 2 squared times 2 factorial, because you do a fraction divided by 2 factorial, it just goes on the bottom of the fraction. All times x minus 1 squared. And then plus f triple prime of 1, which is, and I should say minus again because it's negative, it's obviously an alternating series, you can see, is going to be minus 2 factorial over 2 cubed divided by 3 factorial. So I'm going to say minus 2 factorial over 2 cubed times 3 factorial, and that's x minus 1 cubed. And then plus dot 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 plus. If I want the general term here, okay, I already have the general term from my Taylor series, but instead of fn1, we're plugging in this derivative. So I'm going to try to squeeze it all in here if I can. I might have to erase just a little bit here. Plus dot dot dot. That's going to be negative 1 for my alternating series, and I'm writing this here pretty much. N minus 1 factorial over 2n divided by n factorial. Okay, and then times, so that's, I wrote this piece and I wrote this piece. Okay, and then times x minus 1 to the n. So there you have it. That's the general term. Now, this is the answer. When I did this problem, I left the answer like that. All I did was plug in what my derivative formula is, n factorial and x minus 1. And honestly, guys, I left it this way. I did not simplify it, and it is fine to leave it this way. This is the Taylor series representation using the criteria given above. I just plugged in values into my Taylor series formula. Okay? But what the answer key did is they recognized a way to simplify this. They saw like 1 factorial over 2 factorial, 2 factorial over 3 factorial. They simplified n minus 1 factorial over n factorial, which if you didn't do that, it is completely fine. But I will go ahead and do it because it's going to make the next problem a little bit easier for us. So I'm going to say this is the same thing as 1 minus 1 half x minus 1 plus 1 factorial over 2 factorial is just 1 over 2. So that's going to be 1 over 2 squared times 2, x minus 1 squared. And 2 factorial over 3 factorial. This is the same thing as saying, like, on bottom, 3 times 2 factorial, right? We've done that before. So the 2 factorials cancel. So I'm left with 1 over 2 cubed times 3, x minus 1 cubed. So what happens, like what the pattern is that happens, is that n minus 1 factorial over n factorial reduces to just, if you think about it, n factorial is the same thing as n times n minus 1 factorial. So the n minus 1 factorials cancel, and I'm left with just 1 over n. So really the general formula is negative 1 to the n. All right, and that's going to be over 2n times x minus 1 to the n. So what happened was that the n minus 1 factorial over n factorial reduced to 1 over n. Okay. If you left it as the first circle, that's fine, but this second circle is going to help us just a little bit later down the road, so I wanted you to kind of keep that in mind. Okay, so there's your answer. That's the first 4 terms of my Taylor series and the general term. So have this written down, that general term there, because that's going to be helpful for a later problem. Okay, again, this general term would have been just as helpful, but it's just a little bit more math, right? Okay, let's move on. All right, now, this next problem looks scary, but it's not bad. It says the Taylor series for f, which we just found. We just found the Taylor series. I'm going to go ahead and write that general term down so we can memorize it, or so we can have it available. The Taylor series was the summation n equals 0 to infinity. And remember how it simplified. It was the alternating piece, negative 1 to the n. And it was over, make sure I wrote that right, over, 2 to the n. Times n times x minus 1 to the nth. Okay, so that's what the general term, that's what it's simplified down to in part A. So this is the Taylor series for f about x equals 1. Okay, so that's good to keep in the back of our mind. I'm already telling you that this has a radius of convergence of 2. And I want you to find the interval of convergence and show your work that leads to the answers. Well, that's not hard at all. First off, if x equals 1 is my center, okay, so I'm saying that like absolute value of x minus 1 is my center, and I'm saying that the radius of convergence is 2, so that's going to be less than 2. That's the answer, really. Okay, so if we write that out, that's x minus 1, and that's negative 2 and 2. So if I add 1 to both sides, that's 3 and negative 1. So that's my interval of convergence. It's between negative 1 and 3. 1 being in the center and the radius from 1 being 2. The only thing is, we don't know if negative 1 and 3 is included in that interval, so we have to see if it is. Now, I would see part A being on the final exam. Part B, this is not required. It's using the ratio test to figure this out. But because interval of convergence is not on there, they took that part out, but it's still helpful. So remember how we tested these. We tested these by plugging them into the function. So we're first going to test, how about negative 1? So we're going to let x equal negative 1 and plug that in. That's going to be the summation n equals 0 to infinity of negative 1 to the n. And negative 1 minus 1 is negative 2 to the n over 2n times n. Now, I can see them asking you if this converges, okay? So it's actually not that bad. They didn't give you an x value, they just gave you all n's. So if I want to do this, maybe I'll simplify down this piece first. I'll split off that negative 1 to the n. So this will be like negative 1 to the n times negative 1 to the n is going to be negative 1 to the 2n, and I'm left with 2 to the n over 2 to the n times n. You see what I did there? I made this the same thing as negative 1 to the n times 2 to the n. And the negative 1 in the n and the negative 1 in the n become negative 1 to the 2n. Here's the interesting thing, is the negative 1 to the 2n is always going to be raised to an even power. That's always going to make this positive 1, so that goes away. And the 2 to the n's go away. So what I'm left with, what this simplifies to, is the summation n equals 0 to infinity of 1 over n, which we know what that is. That is the harmonic series. And we know, based off of p series and harmonic series, like with p being a power of 1 here, that the harmonic series diverges. So I'm going to say harmonic series diverges. So negative 1 is not included in the interval. What about if I let x, dude, that bothers me so much. Look at that. What is going on over here? Why can't I plug that value in? Is there something wrong with my computer? I don't know. Man, it bothers me so much. So we're going to let x equal the other endpoint 3. Okay, so that's the summation n equals 0 to infinity of negative 1 to the n, and 3 minus 1 is going to be 2 to the n over 2 to the n times n. All right, well, now what happens is the 2 to the n's cancel, and this is the same thing as summation n equals 0 to infinity of negative 1 to the n over n, which, if you remember, this is the alternating harmonic series. Okay, and the alternating, and you can do the test for alternating series if you really want to, but the alternating harmonic series we learned converges. Okay, so in our final answer, we include 3 in the interval, but not negative 1. So there you go. And if you wanted to test the alternating series test, which is part of our curriculum now, remember the alternating series test for convergence for this was number 1, to test the limit as n approaches infinity of a sub n, or 1 over n. and that does equal 0, so that's criteria number 1. And number 2 is that if I take the derivative of 1 over n, I get negative 1 over n squared, and that is always less than 0, so therefore it is always decreasing. So that's the alternating series test for convergence, is the fact that number 1, the sequence 1 over n goes to 0, and that the derivative of 1 over n is always less than 0, so it's always decreasing. So ultimately it's decreasing. But anyway, this is my final answer. So there you have it. Some like streak right here. I'm sorry, I just don't know why I cannot write right here. Did I mess up my computer? Okay. Anywho, I should probably erase all that. Okay. Let's move on to part C. Part C says the Taylor series for f about x equals 1. Now I can see C being on there for sure. It says the Taylor series for about x equals 1, which we found in A. We found that in A, can be used to represent f of 1.2 as an alternating series because that's within our interval of convergence. And we're going to use the first 3 non-zero terms of the alternating series to approximate f of 1.2. Easy. Remember that the f of x is equal to, those first 3 non-zero terms from part A were 1 minus 1/2 x minus 1. This is the simplified version. 1 plus 1 over 2 squared times 2 x minus 1 squared. Those were the, and then plus dot dot dot. Those are the first 3. So if I want to use the first 3 terms to approximate 1.2, you just plug 1.2 into that. So f of 1.2 is approximately equal to 1 minus 1/2, and then 1.2 minus 1 is 0.2, plus 1 over 2 squared times 2 is 8, and that's 0.2 squared. And that's the answer to C. Calc inactive, you could probably leave it that way, but let's simplify it a little bit more if we can. That's 1 minus 0.1 plus 1/8 times 0.04, which is 1 minus 0.1 plus 1/8 of 0.04 is actually 0.005. Yeah, because it's like doing 0.040 divided by 8, and that's 0.005. Yeah. All right. And combining those together, we get, let's see, 0.905, I believe. Okay. So that's not bad. As long as we have the series, we can approximate any point on the interval of convergence by just plugging it in to however many we want to. It says the first 3 non-zero terms. That's what I did. Okay. And then lastly, D. I'm running over 30 minutes, so I'll try to keep this one short. It's not too bad. Show that the approximation found in part C. So show that approximation is within 0.001 of the exact value of f of 1.2. Now, because this is an alternating series, how I show the error in my approximation and the actual value is based off of this. Remember how it works. The sum minus the partial sum is less than the next term in the sequence. Okay, that's just the error bound for alternating series, which we know that this alternating series is both, it converges to 0 and is decreasing. So we can do the alternating series test. Okay, so in this case, this is like saying f of 1.2 minus my approximation of 1.2, which I found to be in part C, what was it, 0.905, is going to be less than the next term in the sequence, which if you look at part A, okay, the next term in the sequence was that cubic term, which was 1 over 2 cubed times 3 times 1.2 minus 1 quantity cubed. So we just got to show that that quantity is actually less than 0.001. Okay. So if I solve this out, I get, let's see here, that's 0.1 cubed, or 0.2 cubed, so that's 0.2 cubed over 8 times 3, which 0.2 cubed is 0.008, I believe. Yeah, over 8 times 3, which 0.008 is 8 over 1,000, 8 thousandths over 8 times 3, which if you do some same change flip here, is going to be equal to 8 over 1,000 times 8 times 3. And the 8's cancel. So this is the same thing as 1 over 1,000 times 3, or 1 over 1,000. So I got that f of 1.2 minus 0.905 is going to be less than, so that error, that approximation is going to be no more than a difference of 1 over 3,000, which is less than 0.001, because 0.001 is 1 over 1,000, which is greater than 1 over 3,000. So we just showed it. Okay. So that was just an error bound. An error bound is not going to be on the final exam, but it is, just part of the curriculum. So I figured we'd go over it. And yeah, so I'm over my mark here, but let's just go over the answer key real fast. I know this was a tough problem, guys. I apologize, but if you can get A and C, I think you're doing okay. The first two terms, the third term, and the fourth term. So you get 3 of the 4 points for getting this part here. And again, they simplified it a little bit. We didn't originally, and if you left it in the unsimplified version, you're fine. As well with the general term. If the general term was not simplified all the way down, you would have been fine too. Identifying both endpoints for B to be -1 and 3, and that's just taking my center and adding and subtracting 2. And then the analysis of the intervals of convergence. So testing x equals -1 and x equals 3, and they discussed harmonic and alternating harmonic series, and they got the same intervals of us. Part C, we got the approximation to be 0.905, just using the first 3 terms from part A. And D, we did the error form, which was the alternating series error bound. And then the analysis is the fact that 1 over 3,000 is less than 0.001. It's a tough problem, but A and C is the main ones I want you to get. And yeah. All right, well, that's enough talking for today. So good luck. Let me know if y'all have any questions, and we can talk through any of it. So see y'all.